For a second, we thought they were aliens. In the case of Tabby's star, the star more formally known as KIC 8,462,852, the data and an accompanying photo of towering figures was weird enough that a few people surmised it may be pointed to a sign of an alien civilization. The odds were never good, and a paper published earlier this week shows that aliens almost certainly aren't involved. Instead, astronomers think the abnormalities are probably either dust orbiting the star, fragments of comets, or even variations in weather on the star's surface. These possibilities are a lot more boring than aliens, but that doesn't mean Tabby's star isn't interesting. The very fact that we still don't know exactly what's going on other than, it ain't aliens, is itself interesting. Tabby's star is one of many observed by the Kepler Observatory, a space telescope designed to hunt for planets orbiting other stars. Because there are so many of these stars in Kepler's catalogue, astronomers recruited citizen scientists through a project called Planet Hunters to help sift through the data. Planets passing in front of their host star will block a small percentage of that star's light. That dip in light predictably happens once for each orbit of the planet. However, the star the Planet Hunters found in 2011 fluctuated wildly and randomly, showing much larger decreases in light than any planet. Professor Tabitha "Tabby" Boyajian, an astronomer at Louisiana State University, led the follow-up observations to study the weird star, which was nicknamed in her honor. Astronomers proposed many explanations, but Penn State astronomer Jason Wright caught the public's attention in 2015 with his alien megastructure hypothesis. The idea, familiar from science fiction stories, is that very advanced civilizations might build a kind of space station that circles completely around a star as a ring or sphere. During construction, Wright proposed the individual pieces of that structure might absorb light in random intervals, like we see from Tabby's star. The idea was always a long shot. We don't know what the odds are in favor of alien life of any kind, much less the odds of a technologically advanced civilization growing powerful and wealthy enough to spend its resources on a project of that scale. To put it another way, we on Earth have enough trouble cooperating between nations to get anything done about climate change, an issue that affects our long-term health as a species, so cynically we have to wonder how big a threat would be needed to get us to cooperate on a megastructure. Then there's timing. The aliens would have to be constructing their megastructure during the brief period of time we're watching them do it. I don't think any scientist legitimately considered the megastructure hypothesis more viable than any other explanation, due to a lack of evidence, Boyajian's graduate student, Tyler Ellis, told the Daily Beast. To put it another way, there was no compelling reason to think these random fluctuations in Tabby's star had to have an extraordinary explanation, just because we couldn't immediately pin them on a more mundane source. But the real answer has to be given by science, and that requires data in the form of astronomical observations. That's harder for Tabby's star than it is for many other objects in space, and not just because it takes light from the star 1,000 years to reach us. The thing to remember is that we don't have a picture of very many stars. They're mostly single points of light even in our strongest telescopes. Instead, astronomers measure the light from a star over and over to see how it fluctuates, like single frames of a movie. Putting all those measurements together creates a light curve. The light curve for Tabby's star was very erratic, which means if there were any patterns to it, they wouldn't show up without observing the star for a long period of time. For that reason, Boyajian and her colleagues raised over $100,000 from 1,700 donors through Kickstarter to pay for enough observatory time to measure the light curve from March 2016 through December 2017. They used the Las Cumbres Observatory, which is a network of automated telescopes distributed around the world. Given that the observations are done robotically, it is possible for observers to request exactly what we needed, a few pictures every hour or so, Ellis said. He points out that almost none of the usual funding agencies would be willing to pay for such continuous observations, which is why Kickstarter came in handy. You are now subscribed to the Daily Digest and Cheat Sheet. We will not share your email with anyone for any reason. With 22 months of data, astronomers were able to identify 4 major patterns within the fluctuations of light, which they named with the help of their Kickstarter backers. The largest was nicknamed Elsie, which is a pun on Elsie for light curve. The second was named Celeste, in memory of the mother of one of the researchers. The astronomers gave it a secondary justification, Elsie or LC in reverse is ciel or ciel, which means sky or heavenly in French. Celeste is the original Latin name from which seal is derived. The final two features were named Skara Brae and Angkor, after two significant cities which were abandoned for unknown reasons hundreds of years ago. Boyajian and her co-authors point out the analogy between Tabby's star and these historical mysteries. They are almost certainly caused by something ordinary, at least on a cosmic scale. And yet that makes them more interesting, not less. But most of all, the mysterious. What the heck was going on there, all those centuries ago? In addition to the duration and patterns of the fluctuations, the astronomers also measured the particular colors of light wavelengths, in scientific terms, that were being absorbed. That's ultimately why they concluded it's probably not aliens. A giant rock or metallic megastructure would be opaque in all kinds of light, but the observations showed different colors were absorbed more strongly than others. The culprit, then, is probably something that lets some light through more than others, but doesn't emit any detectable light of its own. To astronomers, that says dust, small clumps of molecules made of carbon and other common chemicals. The dust would have to be in clouds of possibly changing shapes and sizes to explain the erratic dips in the light curve. It's also possible the star itself has some sort of weird weather that accounts for the fluctuations of light, but we've never seen a starstorm like that anywhere else. Ellis points out that the observations aren't in the right wavelengths to tell us exactly what kind of dust this would be, so the story isn't done yet. The dust hypothesis is probably the right explanation, in other words, but it's too soon to say that for certain. It may not be aliens now, but thanks to Kepler and other planet-hunting observatories, we think our has hundreds of billions of planets. While megastructures are highly unlikely, the longer and deeper we look at the night sky, it seems only a matter of time, whether that's years or centuries, until we can say yes, it is aliens this time.